access or the purpose of internet, information extraction from the internet or even digital device by itself. So this requires the existence of the various applications, natural language application particularly, which like that spelling checker or the machine translation system or the search engine in general. And as you know that in Ethiopia, most of language, almost all language are under scarcity natural language processing tools, which is publicly available. Like there is no post-tagger, there is no name entity cognizer. Even there is no plenty of corpuses which is to train the machines. So with this in mind, the purpose of this study or our goal is to work on investigating how well the tools, those are already experienced before, and also that can be transferred between the linguistic. As you know that we are very rich in linguistic in our country, and to develop the resource as well different tools that can be transferred for other language also. So the first tool that we have developed is the morphology analyzer, right? So as you know that most Ethiopian language, including Amharic and Afan Oromo, it is highly complex in morphology, so that it needs some pre-processing tool for development of any advanced natural language processing, right? So morphology analysis performance in two ways, as you know that. The first one is lemmatization and also the stemming, but in our study, lemmatization is used in detail. So this is our tools result. So this is how our analyzer works. So another tool that we have developed is the part of speech tagger. The part of speech tagger, as you know that part of speech tagging is classifying each word in a sentence into their lexical categories, or also we can call part of speech tagging is labeling each word in a sentence into their syntactical category. So in morphology, in the morphologically rich language like Amharic, as I've told you, the part of speech tagging is still not solving problem. That's why we have initiated to develop the one advanced as well cutting edge tools. As you know that part of speech tagging is the basic block for different kind of advanced natural language processing. So still it is an open problem for Amharic, also for Afan Oromo. This is the trend for or the experiment or different scholars have been engaged in different part of speech tagging tasks. So the maximum accuracy yet achieved is 93.6. So this is the best model yet available on the papers. But as you can see, as you know that in English language or in different Western language, the accuracy is already human level, okay, which means about 99. If you know Stanford post-tagger, which could able to achieve about 99% accuracy. So we are much behind or much lag behind for other competitive languages. So that by having this bottleneck, we are proposing a new model, which using a deep learning model. As you can see here, only one study is attempt to use the deep learning algorithm, the so-called LSTM, and also BILSTM also. So that we have proposed the new model by using a deep learning model. So we have implemented the joint architecture, which is a CNN as well LSTM. So CNN used for feature extraction purpose, whereas the BILSTM is learning purpose. So there are three layers we are already encompassed here. So the first one is CNN as encompassing with the LSTM. Here there is a bidirectional LSTM also analyzed, and then the CRF model at the output layer, okay? So this is how we proposed, the architecture of our proposed model. As you can see here, there is an input tokens. So every token in a sentence considered as an input, as you know that. And so there is embedding layer. So we considered two embedding. The first one is the word embedding, the one which is very common. And what we make advanced, what we added in this study is character level embedding also involved. And then after there is concatenation, there is also BILSTM, and at the output for the classification purpose, we have analyzed two classifiers. The first one is, as you can see here, there is a softmax, the one which is very well known, and also another one is of the deep neural network model. First of all, what we have done is a collecting of a corpus. So collecting of a corpus, so we have tried to collect two different corpus from two different sources. The first corpus is collected from Ethiopian Language Resource Center, as you know that. So this corpus actually is very common. Most scholars using this corpus. But in addition to that, we have annotated another corpus manually, which is which is collected from different website sources, so which is basically a religious corpus, and it is about it's more than 111K. Annotated with 62 post tags, but the above one is 31 tags. And what we make is 31 post tag is very common as well. Different scholars, Professor Baye, advise that 31 post tag for Amharic is enough for representation of grammatical perspective. Though that what we have done is converting this 62 post tag into 31 just to make equivalent. And finally, we got best accuracy while we are using or while we are combining the CNN as well by LSTM and CRF, about 97.23% accuracy. Actually, we have evaluated a lot of models also, but maximum accuracy achieved by combination of these three. And also, this is a graphical representation of how our model is performing. As you can see here, while the number of epochs is increasing, also the number of accuracy also increasing, so they are directly proportional. It's indicated that 13 epoch is the optimal epoch for our model training process. We have also evaluated our model with respect